Hello everyone. So in the last lecture we have discussed about the parameters which will define the state of gas, and those were namely amount of gas, then temperature, then pressure and volume. Right, we were able to find out what is the meaning of these four things and then how they are dependent or not dependent. So we have ended the topic in the last lecture was like pressure is the function of volume, number of mole and temperature, and we have finalized that these all four parameters are interdependent. These all four parameters are interdependent. They are interdependent. Means whenever you will be changing one, the other three will definitely be changed, right? So this is one thing. The one thing I want to make it clear is like how they are connected. So they are connected in an equation called ideal gas equation. Which equation? Ideal gas equation. And how they are connected? This is like PV equals to nRT. Pressure multiplied by volume is equals to number of moles into R into T. So P is nothing but pressure. You all know this. Pressure. V is volume. T is, point to be noted, absolute temperature. Do not call it temperature. Then N is number of moles. And what R is? R is called universal gas constant. Universal gas constant. What is the meaning of this universal term? Universal does mean that the value of this constant will not be affected by anything. There are two types of constant. One is universal constant, another is characteristic constant. Characteristic constant is something which depend upon the character of particular substance. Like if we are dealing with boiling point, right? So boiling point of water is 100 degrees Celsius. Boiling point of ethanol is something different. Boiling point of ether is something different. Like so, although this boiling point of water is a constant, but it is not applicable on all other solvents or on other liquids, right? So point is like this 100 degrees Celsius is the boiling point of water, which is a constant, but it depends upon the characteristics of water itself. What is the meaning of universal constant? Universal constant does mean that whatever be the thing, whatever be the gas, whatever be the other factors, the value of this gas constant will not be changed. If you ask me what are other these universal constant, you must have heard the name of universal constant, universal gravitation constant, capital G. Like other the same constant like this, they are called universal constant. Means not affected by any other factor. Simply not affected by any other factor. Not affected by any other factor is called universal constant. And since we are dealing with the gas, so universal gas constant, as simple as that. Okay, so now need to understand what is the value of R. So I'll be giving you four values for R. What are those values? 0.0821 liter atm per Kelvin per mole. Then 0.083 liter bar per Kelvin per mole. Then 8.314 joule per Kelvin per mole. Then another 2 calorie per Kelvin per mole. These are the four values of universal gas constant, and these are the four values. If you now ask me what is the physical meaning of this? Physical meaning of R. So now again focus. per Kelvin per mole, per Kelvin per mole, per Kelvin per mole, and per Kelvin per mole. This is common in all 4 units. Okay, right. It clearly indicates that this liter atm, this liter bar, this joule and Kelvin should have the same dimension. What I'm saying, if all these values are representing a same physical quantity, it clearly indicates that they all should have the same dimension. Yes or no? Yes. And if they have same dimension, this is clearly mentioned, per Kelvin per mole, per Kelvin per mole, per Kelvin per mole, per Kelvin per mole. So all these are equal. It means liter atm, liter bar, joule and calorie, their dimension should also be equal. We are very much familiar with this joule and calorie. These are nothing but the units of work done or energy. So the physical meaning of R is work done by gas, work done by gas per Kelvin per mole. Work done by the gas per Kelvin per mole. Work done by the gas per Kelvin per mole. Okay. Work done by the gas per Kelvin per mole, and that is the physical meaning of R, right? If we are dealing with this ideal gas, we must not forget two things. We must not forget two things. And any gas will be behaving like an ideal gas if we are having one thing like intermolecular attraction forces to be zero. And this intermolecular attraction force can be zero if the gaseous particles are far apart, and they will be far apart only when the pressure would be tending to zero. Pressure would be tending to zero. If the pressure is very low, I am saying one thing very important, if the pressure is very low, at very low pressure, the gases would reach to ideal behavior. Gases would reach to ideal behavior. If the pressure is very low, the gases will reach to the ideal behavior. And here, what gases I'm talking about? These are the real gases in which we are surrounded with. We are surrounded with the real gases, right? So this is done. This is done. So now we are having this equation, ideal gas equation, PV equals to nRT, in which I have cleared all the things, what is pressure, what is volume, what is number of mole, what is gas constant, and what is temperature, right? Now I would be taking the same thing here, and this is going to be a very, very beautiful thing for you. Okay, so can we write like this? Can we write like this? PV upon NT equals to R? Yes, we can. And since R is a constant, we can simply write PV upon NT is a constant. Yes or no? Yes, we can do this. And if this is constant, so let us try to assume that there is a pressure P1, volume V1, temperature T1 and moles N1. Again, P2, V2, T2 and N2. Pressure P1, volume V1, N1, T1, P2, V2, N2, T2. Means I am talking about two states. This is a state 1 because the parameters are different. This is a state 2 because the parameters are different. If the gas is same, I can simply say P1 V1 upon N1 T1 equals to K. That is another constant. Let's take R. And this R is also equal to P2 V2 upon N2 T2. This clearly indicates that P1 V1 upon N1 T1 equals to P2 V2 upon N2 T2. And this is a very good equation. This will definitely help you in working with numerical problems. P1 V1 upon N1 T1 equals to P2 V2 upon N2 T2. Right. So we are, till now we have reached up here. Okay. I just want to make some terms very familiar with you. I just want to make these some terms familiar with you, and these are the terms like closed container. These terms usually come closed container, open container. These terms you will be seeing doing when you will be doing the numerical problems. Closed container, open container, then fixed container, or simply like rigid container, or flexible container. These four things, what? Closed container, open container, rigid container, flexible container. These 3-4 terms usually come during the numerical questions, and they definitely make their huge impact while you are solving the questions. And if you are not familiar with these 3-4 terms, you will be missing the right answer. Okay, come. Closed container means the gas is trapped, and if the gas is trapped, their number of moles are equal. The gas is trapped, their number of moles are equal. Open container, the moles are not equal. N1 is not equal to N2. Rigid container, volume V1 equals to volume V2, and flexible container, volume V1 is not equal to volume V2. These are some simple meanings. I'll write here, N1 is equal to N2. If the container is closed, the gas is trapped, so their moles will be fixed. The moles will not be changed. If the vessel is open, some sort of gas may come or may go out, so moles are not conserved here. Okay, so moles are conserved in closed container, moles are not conserved in open container. Rigid container, volume remains same. Flexible container, volume is not same. Simply, so these 4 things will definitely help you while you will be doing your numerical questions. Okay, so this is actually the meaning of some important terms, and I have explained you this ideal gas equation. Again, I'll be just clearing it out, and then we'll do something further. We have landed up here. P1 V1 equals to P2 V2. P1 V1 upon N1 T1 equals to P2 V2 upon N2 T2. Right. Now we will be doing gas laws. The most awaited thing, gas laws. First gas law, second, third, and fourth. There are 4 gas laws primarily. The first one is Boyle's law. Then other is Charles' law. Then the third one is Gay-Lussac law. Gay-Lussac's law. And the fourth one is Avogadro's law. And I will be very happy to say this. You'll be getting a question in NEET from here, definitely. Boyle's law, Charles' law, Gay-Lussac law, and Avogadro's law. Definitely a question in NEET from here. What are the conditions for Boyle's law? N and T constant. N and T constant. Here, N and P constant. Here, N and V constant. Here, P and T constant. P and T constant. Okay. Now try to understand. This equation will help you very much. N and T constant, this is equal to this, so this will be equal. We can say simply like P1 V1 upon NT equals to P2 V2 upon NT. This will be cancelled, so you will write P1 V1 equals to P2 V2. You will land up here. You can simply say P1 upon P2 equals to V2 upon V1. You will simply land up here, and then you can say that V is inversely proportional to P. Very good. Means for a given amount of gas at constant temperature, the volume of gas is inversely proportional to its pressure. This is the statement which is usually written in the book. I repeat the statement. For a given amount of gas, that is N is constant, at constant temperature, T is constant. For a given amount of gas for at constant temperature, the volume of gas is inversely proportional to its pressure. Boyle's law is ended. Again, come for Charles' law. N and P constant. So we'll write like P V1 equals to P V2. P V1 upon N is constant, N T1 equals to P V2 upon N T2. So P cancel, N cancel. What is there? V1 upon T1 equals to V2 upon T2, or simply V1 upon V2 equals to T1 upon T2, or simply V is proportional to T. What is the meaning of this? What is the statement of this? For a given amount of gas at constant pressure, the volume of gas is directly proportional to its absolute temperature. Can we feel it? For a given amount of gas at constant pressure, the volume is directly proportional to its temperature. It clearly indicates when you will rise up the temperature, the pressure, the volume will rise, and when you decrease the temperature, the volume will decrease. Temperature increased, the volume increase means that it will be expansion, the gas will expand, and if the temperature is down, the gas will compress. Expansion and compression. Expansion and compression. So by increasing the temperature or decreasing the temperature, we can simply make the gas expanded or compressed respectively. Gay-Lussac law. So we are having N and V constant. We are having N and V constant. What is the meaning of this N and V constant? So let us again write. So P of P1V upon N T1 P2V upon N T2. So here N and N cancel, volume and volume cancel. So you will have P1 upon T1 equals to P2 upon T2. That makes P1 upon P2 equals to T1 upon T2. That is P is proportional to T. P is proportional to T. What is the meaning of this Gay-Lussac law? For a given amount of gas, if you make the volume of the gas constant, when you will be heating the gas, the pressure will increase. In the last lecture, I have told you that whenever you will be increasing the temperature, the gaseous pressure will increase, provided rest two things, number of moles of gas and volume of gas remains constant, right? So here, when you will be increasing the temperature, the pressure will increase, and you will be decreasing the temperature, the pressure will decrease. So this is the meaning of Gay-Lussac law. We can simply understand this, right? Again, come to Avogadro's law. What is the meaning of here? So you will be writing P V1 upon N1T equals to P V2 upon N2T. Here P cancel, T to T cancel. V1 upon N1 equals to V2 upon N2. That's simply V1 upon V2 equals to N1 upon N2. That is V proportional to N. What is the meaning of this? At given pressure and temperature, the volume occupied by gas is directly proportional to the population, or simply you can say the moles of gas. Because why I use this word population? Because whenever there will be the increasing number of moles, the more number of molecules will be there, the population will be higher, and the greater population will be occupying the greater space, obviously. So we can simply find out these four laws all together. If we know these four laws all together, if we know this, this simple equation which is known as ideal gas equation, So I will be summarizing this lecture in a whole. First thing, we should be able to understand the ideal gas equation, that is PV equals to nRT. We must be able to understand what is the meaning of R. The meaning of R is work done by the gas per Kelvin per mole. Okay, again we should be doing this simple mathematics, and we will be finding this P1 V1 upon N1 T1 equals to P2 V2 upon N2 T2, and then Boyle's law, Charles' law, Gay-Lussac law, Avogadro's law, and here this is the simple mathematics. Class 7th mathematics is there, and you will be doing this simple cancellation, and you will be getting the very important relations for the two parameters, keeping two constant, we will be able to find out the relation between rest of the two. Keeping two constant, NT constant, NP constant, NV constant, PT constant, and we are here V proportional to 1 upon P, V proportional to T, P proportional to T, and V proportional to N, right? I will be taking the graphical part of these four laws in the next lecture. So that is, the next lecture is very, very important. Actually, this is important too. So the next lecture will be about the graphical representations, or will be based on the how NTA or other competitive exams will be asking the graphical questions based on this. I hope you enjoyed. Thank you very much.